This is part C of a 3-part video series where we're looking at Mark, who's planning for retirement, and he wants to withdraw $1,000 each month for 30 years. His account earns 4.6% interest compounded monthly, and we've already calculated part A and B. That is how much money he will have in his account when he retires, and B, how much money he's going to have to deposit each month for the next 40 years to get to this balance. In this video, we proceed and solve part C, which is how much interest will Mark's deposits earn between now and retirement. This one's solved a little differently than parts A and B. Let's put our thinking caps on and let's talk through this. In order to determine how much interest his deposits will earn between now and retirement, we need to know two things. The first thing is we need to know how much he's actually depositing. So we need to know the amount that Mark is depositing. And the second thing we need to know is how much will be in his account when he's all done. So how much will be in the account? If we have those two bits of information, then we'll be able to determine the interest, right? Because we have a certain amount that he's depositing, then we have an amount that is in the account after the accumulation of interest. And if we subtract those two numbers, the amount in the account, and then take minus that, the deposit he made, that's going to give us the interest. So let's get these two numbers. The first number is, how much is Mark depositing? Well, let's look back at part B. Part B tells us that each month Mark deposits $141.77. $141.77. Now that's each month. Now there are 12 months in a year. So if we multiply 141.77 times 12, that tells us how much Mark is depositing in 1 year. And if we multiply that number times 40, that tells us how much Mark is depositing over the course of 40 years. Let's multiply those out. Now, I'm going to pull out a scientific calculator. You could also pull out the calculator on your phone, or if you're feeling really extra courageous, you can go ahead and do this by hand as well. So let's multiply those three numbers together, 141.77 times 12 times 40. And when you do, you should get the same number as I do. That is $68,049.60. This is the amount that Mark is depositing over the course of 40 years into this retirement account. Now, how much is going to be in his account after these 40 years? Well, that's the amount from part A, isn't it? That was the goal that he was achieving. So after 40 years, he's expecting $195,067. I get that wrong every single time I say that. So $195,067. That's how much will be in his account. So we've got his deposits, and then we've got the amount in the account. And in order to get the interest, all we have to do is subtract those two numbers, don't we? We have to take the amount in the account, $195,067, and we're going to subtract from that the amount that he actually deposits into that account, which is $68,049.60. Again, we can do this by hand or pull out our scientific calculator. To save us some time, I pull out the calculator and I'm going to subtract $195,067 minus $68,049.60, and I get a total of $127,017.40. This would be the amount of interest that's earned over the course of that 40 years. That's $127,017.40. $2.40. That completes part C of this very long problem. So I hope it makes sense. If you have any questions, please don't hesitate to reach out.